So thank you very much. My name is Juan Peña, and I am the CEO of Orbital EOS. And the title of my presentation is EOS Viewer, Integrated Solution for Satellite-Based Oil Spill Monitoring. This is a product that it's quite mature in the market, and in terms of technology, it has already 5 years of development, and it's mainly designed for oil spill monitoring. So I'll talk a little bit about the challenge itself. Of course, I'm sure you are aware of this, but the reality is that oil spills can cause severe disruption to oil and gas operators, including costly cleanups. The cleanup operations can last for some months, and it can imply a severe cost to operators and companies cleaning up the oil. Also fines in some countries, and of course harm to company reputation, which is at the end of the game something that impacts very, very severely when an oil spill happens. In order to address this issue, we have designed this product, which is called EOS Viewer. And it is a digital platform, a web platform designed to help oil and gas operators detect, monitor, and respond to oil spills quickly and efficiently. That is the goal of the product. The company itself was founded by Coast Guard officers, former Coast Guard officers. So we had the opportunity to be in contact with the problem in the field. So we understand, it is our understanding that there are several questions that a decision maker needs to answer when facing this problem. So the first question, the first and very basic one is this one. Is there any oil spill in my area of responsibility? So for that, we use satellites, more than 60 satellites in orbit right now, Earth observation satellites, in order to detect first detection of any potential oil spill that might happen. The second question that usually occurs is, can we be sure if this is indeed a hydrocarbon spill, an oil spill? Because sometimes what we can detect in a satellite image can be natural phenomena, or it can be chemicals, or it can be vegetable oil discharged from ships. So it's very important to understand if what we are seeing in the satellite image is actually an oil spill. And we characterize the spill and we classify them in 3 classes, A, B, and C, that are correlated with the likelihood, with the probability of what we have detected being oil. Another question, which is operationally very, very important to manage the response, is to map the thickness of the oil. Where is the thick oil? And the reason for that is that, unfortunately, there is no technology so far to clean very thin layers of oil at sea. It's totally impossible. So we have to concentrate our efforts in understanding where is the thick oil at sea, and focus our response efforts there. Another question is, okay, how much oil is there in the water? Is something also very, very important in terms of course, legal responsibility, but also oil spill response operations. So how much oil is there in the water? We quantify the oil as well. And then the next question, when we understand where the oil is, and what are the characteristics of the oil, which is the present, we need to understand what is the near future, what is going to happen with the oil in the following hours or days. So where will the spill go? In order to answer that, we use advanced trajectory forecasting models. And also we we simulate how the spill is going to transform in terms of chemical and physical transformation. And for that, we use fluid modeling. Something that is very unique in the product, and as far as we know, there's nothing like this in the market, is that the detection and the modeling is fully integrated. They are fully integrated. So the shape and the characteristics of the spill that we detect in the satellite image are the input for the model to help us understand what is going to happen in the future. So where the oil is going to reach the shoreline, or how the oil is going to transform in hours or days. And that capacity is fully integrated. It's totally automatic, and it runs with no human intervention at all. So I have included here a very short video, because it is my understanding that images speak louder than words. This is a real oil spill event that happened in the Gulf of Mexico to a Mexican oil and gas operator. It was a quite significant accident, real oil spill. As you can see, the oil can be very clearly seen in the satellite image. This is an optical satellite image. The first thing that we do is to characterize this red polygon that represents the thick oil, and the blue polygon that represents the thin oil. Then we include information, of course, about the area covered by oil and also the quantity of oil in the water. That information is shared with the client in form of PDF reports and, of course, access to this web platform. Now you can see this report can be also downloaded from the platform, where you can easily share this information with colleagues or responders in the field. Now we're going to zoom out a little bit to see how the modeling works. It's as easy as you can see. It's very easy. So all the complicated calculations have been done before, and it's fully automatic for the user to run the simulation and see the display of the simulation, how the oil is going to behave. Something very important to understand also is that the thickness of the oil spill is integrated in the modeling, as you can see. So if the pixels are reddish, it implies that the oil is thicker in that part of the simulation. And if it's light color, then it means it's lighter than that. And of course, in case the client has its own GIS system, they can download the GIS file to run their own simulations if they want, or include the information in their own database or GIS system. What are the benefits for the user in our experience? The first of all is cost reduction. As we know, as we have been working for the Coast Guard, we actually work in aerial surveillance, in aerial remote sensing, working on board aircraft, surveillance aircraft. So we understand that using satellite remote sensing is between 10 and 20 times more cost effective than surveillance based on ships, helicopters, or airplanes, which are quite operationally intensive. Then, of course, safeguard your reputation. When you use advanced technologies, you are more prepared to safeguard your public image, because you are ready to respond. You have real-time data, you have real-time information, and you understand the context. And the last one is to demonstrate your environmental commitment. Of course, at the end of the game, we are also committed to safeguard the environment, and that is also something very important to not only to say, but to demonstrate in practical terms. Just a brief description about the company. Orbital EOS was founded by former Spanish Coast Guard officers with more than 30 years of combined experience, real field hands-on experience in oil spill detection, monitoring, and modeling. And this is a portfolio of our current clients. In the Middle East, we have worked for leading companies like Saudi Aramco, North Oil Company, Total in Qatar, and Shell, Repsol, Petrobras in other parts of United States, Europe, and South America, Chevron, and also the European Maritime Safety Agency. So thank you very much for your time. I will be very happy to answer any questions that you may have after this. Thank you.
Thank you, Juan, for the presentation.